In this example, we're going to look at using a trig substitution to solve an indefinite integral. Now here are our three basic trig substitutions that we use, because they're all part of the Pythagorean theorem. So looking at our problem, we notice the 9 minus x squared, which is very similar to this one, so we're going to want to use this a sine theta for our substitution. So our substitution for this one is going to be to let x equal a sine theta. Now this is a little different than u substitution. It's kind of a reverse substitution. Now a in this one is going to be the square root of this number here, so it's going to be 3. Now the one thing you want to remember, always calculate your dx. After you name your x, always calculate your dx, which in this case is 3 cosine theta d theta. Because it's a reverse substitution, all this is going to be getting substituted in. You do not want to forget any of it. So our integral after our substitutions will have 3 sine theta cubed, going in for the x cubed, times the square root of 9 minus 3 sine theta squared, going in for the x squared. Now you cannot forget to substitute in your dx. So we also have a 3 cosine theta d theta. Now we got a lot of simplifying we can do. So first off, let's start in the front. We'll have 3 cubed sine cubed theta. In here we're going to have square root of 9 minus 9 sine squared theta. And here we have a 3 cosine theta d theta. Now, what we are going to be able to do under this radical is we can factor out a 9, and then we can pull that 9 out of the radical. So when I rewrite this, I'm going to get 3 cubed sine cubed theta, 3 times the square root of 1 minus sine squared theta, 3 cosine theta d theta. Again, that move was factoring the 9 out, so we would have had 9 times 1 minus sine squared theta under the radical, and then pulling the square root of 9 out to get the 3. Now I like to pull out all the constants so I don't have to deal with them. I have 1, 2, and 3 more 3's here. So I'm going to pull out a 3 to the 5th. Now I've got a sine cubed theta. And now what I'm going to do here, I have 1 minus sine squared. By the Pythagorean Identity, 1 minus sine squared theta equals cosine squared theta. So I basically have the square root of cosine squared theta, then another cosine theta d theta. So I got 3 to the 5th sine cubed theta. Square root of cosine squared is just cosine times cosine. So I have a cosine squared theta d theta. There's a nice little trick we can use with a u sub to help us out here. And that is, we're going to peel off one of the signs. So I have 3 to the 5th sine squared theta cosine squared theta. Then here's where I'm writing that other sine theta d theta. Alright. What this does is this kind of gives me a hint as to what I'm going to do for my u substitution. Because my du is, I want to have a sine theta d theta, I'm going to let u equal cosine theta, because its derivative is sine theta. Well, actually negative sine theta d theta, but that we can fix. So I need that to be negative, so I add a negative inside, which means I need to add a negative out front. And I now have my u sub almost. We're good here, we're good here. But what about sine theta? Well, we're just going to reverse this Pythagorean identity. Sine squared theta is equal to 1 minus cosine squared theta. So we have negative 3 to the 5th out front, 1 minus cosine squared theta times cosine squared theta times negative sine theta d theta. So we are ready to do our u substitution. Which I'll do here, and then we'll use another page after that. So negative 3 to the 5th times the antiderivative of 1 minus u squared. Cosine is u, so that's another u squared. This part here is exactly du, and we now have a much simpler integral. So we'll write this down on the next piece. Negative 3 to the 5th is the integral of 1 minus u squared times u squared du is where we're at. Now, to solve this, we'll distribute the u squared. So we'll leave the constant out front. Times the antiderivative of u squared minus u to the 4th du. So we have actually a pretty simple, relatively, antiderivative. So negative 3 to the 5th out front, this will be a u cubed over 3 minus u to the 5th over 5 plus c. Now we have to substitute back. Remember, u was cosine theta, so there's our first substitution. So negative 3 to the 5th cosine of theta cubed over 3 minus cosine of theta to the 5th over 5 plus c. Now, cosine theta is also not going to be our final answer. We do need to get this thing back in terms of x. So as a reminder, x was equal to 3 sine theta. Okay. Now there's two ways to recover what cosine theta is. One is to use the Pythagorean identity. One thing I've always liked to do is draw a right triangle. So first thing I do is I solve for sine theta, which equals x over 3. And I like to make a right triangle. You'll see that the Pythagorean identity comes out of this anyways. Sine theta is the opposite over the hypotenuse. So 3, and if we decide to call this angle here theta, the opposite's over here. So that's x. So using the Pythagorean theorem, this is the square root of 9 minus x squared, which, if you remember our original integral, looks pretty familiar. Now I know that cosine of theta is adjacent over hypotenuse. So square root of 9 minus x squared over 3. So we're going to have some simplifying we can do at the end, that we'll do at the end here, but let's go ahead and plug in what we have. So we have square root of 9 minus x squared over 3 cubed over 3 minus square root of 9 minus x squared over 3 to the 5th over 5 plus c. So if we start to simplify, we have minus 3 to the 5th. We'll be multiplying that through in the next step. We're going to take both of these to the 3rd. So I end up with square root of 9 minus x squared to the 3rd over, I've got a 3 cubed over 3. So that's going to be over 3 to the 4th. Minus, we can do something similar. Square root of 9 minus x squared to the 5th over 3 to the 5th times 5, then our plus c. Lastly, I'm going to distribute this negative 3 to the 5th. Notice it completely cancels this out and changes the sign. So, in front. And if we want to, we could write this to the 5 halves. So let's do that. 9 minus x squared to the 5 halves over 5. Now it's going to change the sign on this one. It's going to cancel all of those out, and we'll have 1 left out front. Minus 3 times, let's put this one in parentheses as well, 9 minus x squared to the 3 halves plus c. And that's as far as we are going to be able to simplify that one. We could factor out a 9 minus x squared, to the 3 halves out of each of these, and maybe go a little bit further, but this is fairly well simplified. Not the prettiest integral, but we were able to solve it by hand.